Hi everyone. Today is day 7. So, let's start with solving the problem. Now, I am on ChatGPT. So, I'll say, hey, it is day 7, and here is the problem title. And it is what? Determine credit card defaults using random forest classifier. Oh, nice. So I've been saying that for starters, what you can do, you can read great introductory tutorials on Kaggle, where it clearly talks about random forest classifier. So today is going to be, I imagine today is going to be a short video because I don't think I'll have to read much about this. But yes, but I'll still go give it a try. I mean, try to understand what ChatGPT has to say, and yeah. So what we'll have to do, we have to determine the credit card defaults using a random forest classifier. Again, it is a classification problem. So it says let's break it down step by step and use a random forest classifier to predict whether a customer will default on their credit card payments based on the various features. Okay, we'll have to tell whether the customer will default or not. Now what it says, again the same thing, we'll load the data. It says that we will use a credit card default dataset from Kaggle. So let me go and search this problem on Kaggle, and I can get the problem dataset from this page. Oh, this was like 8 years ago problem. I feels like I started my professional journey from this day, and I mean 8 years ago, and these things are there on internet for 8 years. I'm starting now. It feels like a little bad. So yes, I can see the data. So let me go and use the terminal here. I'm using PyCharm. So I'm saying move the downloads. What did it download with? It downloaded with. Acha, first it has created a zip. So let me unzip it and then go to my PyCharm, and then I guess you see I credit card CSV and move that to dataset section. And can I see? Yes, I can see the information. So what I did, I've downloaded the dataset from this problem from Kaggle, and then I'll go to the second step, and then pre-process the data. Will handle missing values. Oh, today we are going to handle the missing values and encode categorical variables if necessary. We will do again split into test and train data. Feature scaling. We did that. We did feature scaling yesterday in day 6 problem using standard scale. So we will see if it is required. It is optional, but I would love to see how we can do it. Then we will use the random forest classifier. We will build the model and train it on our train data. And then we will use accuracy, confusion matrix, and classification record to access the model performance. You can, yeah. So let's start. I have not created a page for it, so let me go and create a Python file called day7.py. It says, can I add it? Yes, you can add it to the Git repository. So the problem of the day is this: determine credit card defaults using a random forest classifier. So let's start importing the files. I will use Panda so because it is easier to manipulate and visualize data with Panda data frames as PD. Then I am from sklearn scikit-learn library dot metrics. I'm importing, sorry, let me do that later, but let's include what. Model selection in import test train test split from sklearn dot assemble, sorry, ensemble import random forest classifier from sklearn dot matrix import accuracy score confusion matrix classification report. And then we will use matplot library dot py python pyplot as plt to build plot a figure, a graph. And then we will use seaborn as sns to show or have a heat map of our performance of the model. So let's start. We will do what? We will do step number one, which is load the data. So we are using download the data from Kaggle and put it in dataset directory. Okay. If you can see, I've already downloaded and I have put it in the dataset of my root folder of this challenge called, and the dataset, this file is called as UCL, sorry, UCI underscore credit underscore card dot CSV. So let me load it. So it is going to be data frame panda dot data sorry read CSV, and the location is data set UCL correct. I'm going to print dataset df and see what it will print. Day 7. It says I have an error. Oh, I have made a mistake. Let me see what I did in the. See. Okay, now it should load. Okay, I made a mistake. I was putting slash at the start of dataset, so I can see the information. I can do head to see it clearly, not a cluttered response. And see, yes, I can see a lot of features here. ID, limit, bill, sex, education, marriage, age, pay, and bill amount and other information. And then at the end, it says default payment next month. So this is what we have. Let's go back to our ChatGPT suggested solution. Um, Now we are going to pre-process the data. Step 2, pre-process the data. What we do not want this drop payment next month, because this is going to be our target. Okay, so what we do, so the features to train the model are these, and the output, whether the credit card that payment has a default or not, will be decided from this target value. So we'll have to split it. So what we are going to do, this is going to be our feature list. So what we are doing, data df drop, what we have to drop, uh, we have to drop I'll copy here and paste it. Now, if you remember in the last day number 6, we understood that the axis parameter helps us define if we want to delete the row or column. If it is going to be 0, we'll tell to delete drop the row. If it is 1, it will delete the entire drop column. So this will be our features. Okay, then it is going to be data df, it is going to be our target. So let's print it. Print x dot head. I don't see the, see it had 25 columns, now it has 24 columns. Let's see the y. See now, in Y I can clearly see this data defaults, or what I can do, this should do better. Yes, this is my Y. Okay. So yes, I've created the target and feature list. Then the step 3 is going to be what? Split, train, test, sorry, I'll say split the data again. um, Split into 80-20 ratio. Training will go with 80%. I know. And validation data will go with 20% data sets. Okay, so let's do that. I say let's create X train, X validate, then Y train, Y validate, and then use train test split. Tell for X we are going to use to have the variable X. Then for Y train and Y well, we'll have Y. Then we'll do what test size is going to be 0.2, and then the random state is going to be 42. Random state we use to tell uh, that whenever we are generating this split on every run, it is going to be the same. We do that by specifying a random number here, and we are going ahead with 42. It is just a commonly used number, there is no big logic behind it. So we are seeding it with this number so that every time the split occurs similar, right? So this is it. Now we are on the step number 4. Step number 4 is create and train the model. Model. This is modal, not model. MODEL. So it is going to be random forest. I'll say model, and it is going to be random forest classifier. Here we specify an estimator's 100 random. Okay, an estimators it says 100, and then it says random state as 42 again for the randomness. And then we will train this model on our X train, and the values against it is going to be Y train, right? Before I proceed, before I make the prediction, which is the step number 5, make prediction and evaluate. Let's see what does this thing mean here, this estimator. Okay, so let's go. Okay, it explains it, right? I did not read it right. So it says that random forest classifier, we are using a random forest model, which is a collection of decision tree. Okay. We did something with decision tree on day 2, I remember, right? Each tree in the forest is trained on different, so it is a collection of decision tree, and each tree is in the forest is trained on different parts of the data. Each tree in the forest is trained on the different parts of data. The final prediction is made. The final prediction is made by averaging the uh, prediction of all tree. Okay, so we here random forest is being implemented on on a collection of decision trees, and the final prediction is made by averaging the prediction of all the trees. If you remember, we have already saw. Uh, Let me see which problem we did with the trees. No, no. Yes, see, if you remember, we did the breast cancer diagnosis, whether they are malignant or benign, using a decision tree. Here it is going to be a um, collection of uh, decision trees, and the final prediction is going to be the average from all the trees. So I believe it is going to be a better uh, one than decision tree, but let's see how it is going to be. Let me google it. Random forest classifier. Okay, see, this is how it looks like. Right, this is how it looks like. Majority of all the, sorry, the average of all the trees comes as the final solution. Let me go and open this day number 4. Day number 4, we did something with a decision tree, and I remember we had created a decision tree at the end also for the benign and malignant breast cancer prediction. So the decision tree was looking like this, and now here the random forest classifier is a collection of decision tree, and it the result is going to be the average predictions of all the tree. I mean, averaging the predictions of all the tree. So yeah, it makes sense. We'll assess the performance using accuracy, confusion, and classification. And I would love to see how we can draw the decision trees out of it. Though the chat GPT is not sharing about that, how to do that, but yes, I would love to see if we can draw a figure something similar to what we did on day number 4. Yeah, like this. So I would love to see if we can do that. Let me go back and then complete the model. Make predictions. So I'm going to store it in the predictions folder. Sorry, store variable, and it is going to be model dot predict and predict on our validation data. Okay, and then we are going to do what? We will first find the accuracy score using it on our actual value. So it is going to be y value, well will be the actual value, and the predictions the model has made. And then we are going to print the accuracy score is going to be this. So let's go and run this and see how well the model is performing. Let me hide it, the data. The model score is coming as 0.81, like 81%. So it is really good. Let me go and build a confusion matrix, because then we will be able to understand the all the true positives and false positives, true negatives and false negatives. This is again going to be on the actual value and the predictions made by the model. Let's print the confusion matrix, and it is going to be this. And let's clear it and then see how the confusion matrix is coming for this model. And we can see we wanted to, so there were two classes only, whether the credit card has a default or it has, it is not, it has not. So if it is default, it is coming as 4413 and 46924. So it is that we see some good 844 false positive and false negative, and the true positive and true negatives are also good. True negatives I see less. But let me show it using a heat map graph so that we can better understand and visualize it. So first we will get the classification record, and then predictions. Print. Let's print the classification report, and then it is going to be classification report, and then save it, and then see. It's taking some time. The precision for 0 is coming 0.84, for 1 0.63. See, uh, less. The recall value F1 and support. So this is how it is coming. Right. Uh, so let's visualize it. Step number 6 is visualization. So here what we are doing, we'll use PLT, the matplot library, to define the figure of the and the size of the figure, which is going to be 10 is to 7, and then we'll use cbond to build the heat map on our confusion matrix. The annotation, do I want annotation? Yes. The format for annotation is going to be D decimal. Let me see what it says. Yes. And the X tick labels are going to be 01. So I don't want to do anything. We don't need actually here. Let's say that the X label is going to be predicted values, and the Y label is going to be actual values, and then the title of the figure is going to be confusion matrix, and then we will show it. Okay, so see the true, so this is true negative, this is true positive. So this is coming as for 0, it is correctly, it has predicted 441, 4041, 4413 times correctly. For the 1, it has correctly predicted 469 times. It did not predict for 0 value. It did so for 1, it predicted 0. So for 1, it did not predict. So for this value, it is false. Positive is 844, which is a big number, and for 1 it has predicted correctly, um, 469, but wrong, it has predicted 274. So again a big number. That's why the accuracy is coming as, so this is a big number, and yeah, this is also a big number if I compare it with 469. Yes. So yes, the accuracy is coming as is 81%. Now I want to see, uh, if I can improve the accuracy. What do I need to do? Do I need to scale the features? I see the accuracy as 81%. I do I need to scale? Do I need to do feature scaling for better accuracy? What do you think? Hmm. Let's see what it says. Okay, it is still generating. Let it generate completely, and then we are going to understand how we can improve the accuracy. Okay. So we understood. So it says for random forest classifiers, the feature scaling is actually not required. Why? Because it does not rely on the magnitude of the features. In the last day 5, day 6 problem, we saw how we use SVM and how we were required to scale the features because they relied on standard deviation. Now today we see that the decision trees do not rely on the magnitude of the features, rather they rely on the order of the values, that is the comparisons. Yeah, how they are greater as in this decisions. Now for that we do not need feature scaling because they do not rely on magnitude of feature. Uh, Now, if that is not required, should you use scale for better? Even though feature scaling is not essential for random forest, there are few other ways can potentially improve your accuracy. Okay, and what is that? It says that hyperparameter tuning can help us. Yeah, I remember. We did not search about what this is. We forgot actually. So let's understand. It is explaining, right? So it says hyper tuning, hyper parameter tuning. Random forests have several parameters like the number of trees. Okay, so to define the number of trees, we are required to pass these parameters. For this, we are saying that we will be going with 100 trees. Uh, uh, like the number of trees, maximum depth. So the number of trees is this, the maximum depth is, we can define the maximum depth also, minimum sample per leaf is going to be okay, etc. So tuning these can improve the performance. Okay, understood. Check which feature are contributing the most to the model using feature importance. Okay. Handle class imbalance. If your class data set is imbalanced, there are too many. Okay, I do see that there are too many of, yes, these, right? Too many of zeros and too many of, too less of ones. You can adjust class weight using class weight balance in the random forest. So let's try to do something. Let me increase the number of trees to 200 by setting this an estimator parameter to 200. And let's see if it will improve the performance of our model. I do not. I'll remove it. Yeah, the performance is somewhat 4416. So it got improved, but very slight margin actually. 0.81, 0.86, and here also I see 4413, 4417. It got decreased, and we want this and this to go low, and this to increase. So it is increasing, but too less number, very slightly. So let's now do this. Let's set the max depth as 10, and then see if it will improve the performance. Let me hide the this thing, no? Because I don't want to close that again. Again, the performance got improved by increasing the depth of the trees, right? So we see the difference. Now the minimum samples in the leaf node is going to be 4. Let's set that also. Where is our random forest? Yes. So minimum sample leaf are going to be 4. So let's do that and see if it will improve the performance. Oh, it did not. Actually, oh, yeah, it did not. So let's not go ahead with that. Let's do this, increase it. And I'm going to 8.02. Oh, see, the performance got improved when I did this. Increases the minimum sample size. I also want to see how this parameter is going to work, class balance, weight balance, and see if it is going to affect or improve the performance of our model. Uh, oh, it did not. So let's move this. Let's remove this also. Okay, the performance is actually not getting better. So let me not go ahead with this, but keep this. Now we can see the performance of our model has improved a little. What we can do, from 0.81 to I see 82%. So if I increase this to 400 and maximum depth also to 20, it is going to be a very dense uh, forest, but let's see how it is going to perform. It is taking longer. Oh, I see somewhat similar. I The performance got improved a little, so I'll go ahead with this only. So yeah, like- so I'll go ahead with this only. So yes, this is how our model is performing. We learned today how to use random forest, which is a model, a collection of. Let me increase it, which is a collection of decision trees, and the average of the each predict this average averaging the prediction from each tree is the prediction from this random forest classifier. We also learned that we do not need to scale here, because here the prediction does not rely on the magnitude of the features. And we also learned how we can play with improving the performance, the accuracy of our model by the parameters like how many number of trees we want, what would be the maximum depth, would be the minimum samples leaf size. Um, that is the minimum number of samples required to be a leaf node. We say we want minimum number of 8 samples required to be for a node to be a leaf node. And then this random state, which is I've told you about this like 100 times. I'll remove it. Yeah. So this looks promising. I think we can conclude today. uh, Let me go and commit this code, and I'll say git commit git add day 7, and git commit add code for day 7, and then push the code to the main branch, and let's go and see if I see it here. I do see it here. So you guys can get the code from this repository. Now I will go and write a blog, a progress post about it, as in text format, So you guys can go and check out that as well if you would like to. Thank you very much. We'll solve one more problem tomorrow. Okay. Uh, from here I'll stop.